Algebra 2. Today we are looking at Chapter 10, Lesson 2, which is Angles of Rotation. An angle is a standard position when its vertex is at the origin and one ray is on the positive x-axis. The initial side of the angle is the ray on the x-axis, and the other ray is called the terminal side of the angle. An angle of rotation is formed by rotating the terminal side and keeping the initial side in place. If the terminal side is rotated counterclockwise, the angle of rotation is positive, and if the terminal side is rotated clockwise, it is negative. And the terminal side can be rotated more than 360 degrees. Example 1. Draw an angle with a given measure in standard position. So the first one is 320 and it shows it going counterclockwise, which gives you a positive. B is negative 110 and it's going clockwise, so that gives you a negative. And then C, 990, it's rotating counterclockwise. And looking at this first rotation is 360, and then you add another 360, and then the rest of it. So when you're doing this, it just keeps going in a circle until you reach the amount of degrees that you are looking for. Coterminal angles are angles in the standard position with the same terminal side. For example, angles measuring 120 and negative 240 are coterminal because they are both in the same position, even though one is negative and one is positive. There are infinitely many coterminal angles. One way to find the measures of an angle that is coterminal with an angle theta is to add or subtract integer multiples of 360 degrees. So on the bottom, we see example 2, find the measures of a positive angle and a negative angle that are coterminal with each given angle. So if we're using 65, we're going to add 360 and subtract 360, and then that gives you 425 and negative 295, and those angles are both coterminal. Looking at another example, find the measures of a positive angle and negative that are coterminal. So negative 120, you would add and subtract 360, and that will give you 240 and negative 480, and those are both coterminal with negative 120 degrees. For an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Later on we'll learn how to use the reference angles, but we're just going to focus on them for right now. So find the given measure of the reference angle for each given angle. So looking at this, we're looking for this angle right here and this angle right here. But these lines right here are 180. So we know we're looking to get a total of 180 degrees. So one way to do this would be 180 minus 135, and that will give us 45 degrees. So that's the measure of this angle. And then for B, we would do 180 minus 105, and that will give us 75 degrees. To determine the value of the trigonometric functions for an angle theta in standard position, begin by selecting a point P with coordinates x and y on the terminal side of the angle. The distance r from point P to the origin is given by the square root of x squared plus y squared. So on the bottom, sine of theta would be y over r, cosine would be x over r, and your tangent would be y over x, but x cannot equal 0. Example 4, P, so point -6 and 9, is a point on the terminal side of theta in standard position. Find the exact value of the 6 trigonometric functions for theta. So step 1, plot point P and use it to sketch a right triangle and angle theta in standard position, and then find your r. So you would do the square root of -6 squared plus 9 squared, and that gives you 36 plus 81, and that is 117. Then you would take the square root of that and you get 3 times the square root of 13. Step 2, find your sine, cosine, and tangent. And so here you will put your y over your r, your x over your r, and your y over your x, and solve for those. And then step 3, use reciprocals to find your cosecant, secant, and cotangent. So you would just put 1 over your sine, cosine, or tangent, depending on what one you're looking for. Another example, P -3, 6 is a point on the terminal side of theta in standard position. Find the exact value of the 6 trigonometric functions for theta. So step 1, plot your point P and use it to sketch a right triangle and angle theta in standard position and find your r, which is 3 times the square root of 5. Okay, step 2, find your sine, cosine, and tangent. So the same as the last example, you'll find those by using your x, y, and r values. And then step 3, use reciprocals to find your cosecant, secant, and cotangent. And again, you'll put 1 over your sine, cosine, and tangent to find those.